Okay, up till now we have done the study in which our wedge has been fixed on ground. Suppose this is a block on the wedge and we have found the acceleration of the block down the plane. How much was that? This is of mass m, this suppose is also of mass m, and this is a smooth surface but the wedge is fixed. If the wedge is fixed, then the mass m will come down the slope with an acceleration of, if this angle is theta, how much will be the acceleration of the block m down the wedge? It will be g sine theta. We know that. It's a simple case. Now suppose the wedge is not fixed on ground. Wedge can also move. Now first of all, tell me in which direction the wedge will move. From intuition, you can very well feel that the wedge will move to its right. And if you have to say from physics, then you can say that this is a normal reaction acting on the wedge in downward direction because the block is pressing the wedge. So if you take the component of this normal reaction, then the component, horizontal component, is to its right, and that's why the wedge will move to its right. Now the question is, if the wedge is free to move on the ground along, then what will be the acceleration of the entire system? So there will be some acceleration of the wedge also to its right, and the block is moving down the wedge, and along with wedge it is also moving to its right. So what will be the net acceleration of the block and what will be the net acceleration of the wedge? You have to find that. This is a good problem after learning the basics in Newton's second law up till now, and after learning the constraint motion, you must be having a good hand over this now in order to solve this kind of problem. It's not difficult, you just have to draw the FBD and analyze that. So spend some good quality time trying to solve this problem. Okay, let's discuss how to go about solving this. Let's see. Suppose the wedge has an acceleration a to its right. If wedge has acceleration a to its right, then along with it, block is also moving. Block is not leaving contact with wedge. So block also should have this component of acceleration. So block should also be moving to its right with acceleration of a, because there's the contact between block and the wedge is there always. And apart from that, apart from movement of the block along with wedge in horizontally right direction, the block would also be coming down the plane of the wedge. Fine. So the block will also have some acceleration down the plane of the wedge. Let that acceleration be b. Okay. Now there are two kinds of motion. One, the whole system as a whole is moving to its right, and the other from the reference frame of wedge. With respect to wedge, relative to wedge, the block is coming down the plane of the wedge. So we can write two separate equations of motion, and we would try and solve A and B for that. So let's look at the horizontal component. Now, how much is the force for the wedge and the block as a whole? Considering wedge and the block as a system, how much force is acting in horizontal direction? Well, there is no external force for the wedge and the block in horizontal direction, right? Because this normal reaction is an internal force for the whole system. So there is only normal reaction, and from this ground, which will be vertical, that is and plus the mg, which will also be vertical, that will be the external force. So the net external force in horizontal direction is 0, and that should be equal to mass into acceleration. For the wedge, mass into acceleration, plus for the block, mass into acceleration a. In the horizontal direction, mind you, it's not only a, the acceleration is not only a, the acceleration would be a, and there will be some horizontal component of b as well. So we are looking for net horizontal force, then we must be looking for net horizontal acceleration. Now there will be some component of b in horizontal direction, that will be b cos theta in opposite direction. So A minus B cos theta is the net horizontal acceleration of the block. Now this is the net, this should be equal to net horizontal force for the system, which is 0. So this is one of the equation that we have written. Now you understand this properly because you must get the things right straight away in this problem itself, and for the other you should not linger and struggle. What we are doing is we are writing the equation of motion in the direction where we have a clear-cut motion of the body. In horizontal direction, the whole system is moving. We have written one equation of motion in horizontal direction. The other dimension of motion will be down the plane, in the plane of the wedge. Now we will try and write the motion equation of motion for this block along the plane of the wedge. Now along the plane of the wedge, what is the external force for mg, for the block M? For the block M, one force will be mg vertically downward, and normal reaction that will be perpendicular to the plane, and that will have no component along the plane. This angle is theta. So along the plane it is mg sine theta, right? So mg sine theta is the net external force for the block along the plane. And how much is the acceleration of the block along the plane? That is b minus a cos theta, isn't it? Net acceleration along the plane. So this is the net force, and mass times the acceleration, that should be equal to the net force. So you have two variables, a and b, and you have written brilliantly two equation of motion. Now all you have to do is get your act together and solve these two equations and find a and b. That's it. So work this one out. I'm not going to solve the equation for you. You have to work. Me solving the equation is not going to help you. Only you solving the equation is going to help you. So solve these two equations and find the value of a and b. It will be a good exercise for you. And the value of a that you should come out with should be sine g into sine theta into cos theta upon 1 plus sine square theta. And b should come out as 2 into g sine theta upon 1 plus sine square theta. You got the value of a and b? Very good. Now the question was not just to find the value of a and b. The question was what is the acceleration of the wedge and the block. Now the acceleration of the wedge, the acceleration of wedge will be equal to a I cap. So you can just put the value of a here and you can report the acceleration as this I cap. But the acceleration of block, is not simply in terms of a and b. It is actually a minus b cos theta I cap, right, minus b sin theta j cap. This is the acceleration of the block, and you have to put the value of a and b and again simplify it to give the answer as the acceleration of the block. That will fetch you full marks, and that is what should be done ideally. You should always report the acceleration when you have acceleration in horizontal and along an inclination. Report the acceleration in the form of I cap and j cap. So you will have to do a little more exercise in putting the value of a and b here, and finally you must get the acceleration of the block in this form. This is simple manipulation. This is not physics, right? So on this you are on your own. Fine. So this should be the final answer for you. So it was not difficult. It's simply the Newton's second law of motion. That is what we are dealing with in the whole chapter. Okay. So if this was simple, the next question should be simple also.